Welcome back to the next installment of Adventures in the Library. We're really starting to roll along now as we get into carbohydrates, and this is what we're going to do. We're going to start off right away in carbohydrates because we had gone to nucleic acids and nucleotides, got into the first few paragraphs, and it said to reference, and it referenced carbohydrates. So we went to see what carbohydrates was, and now we're in carbohydrates. We were talking about sugars and starches. We know that the sugars in carbohydrates are the monosaccharides, and the starches are the polysaccharides. So as we continue on in here, looking at the structure here, basically what I'm seeing here in the structure and here we go. We're looking at these things called there's these figures that they have in here, these molecular diagrams. They're called Hayworth structures of alpha D glucose, right? And it says Ferguson textbook of organic chemistry, right? And all of these diagrams, when they reference where they got the material from, they all come from organic chemistry textbooks. So at this point in time, what I'm going to do is that rather than simply continue on looking at the sugars, what I'm going to do is, because we need a more basic understanding of things, we're going to go over to organic chemistry. And so I confirm my suspicions that we are dealing with organic chemistry when we're dealing with carbohydrates, and that means because carbohydrates is so linked with nucleotides and nucleic acids, that more likely than not, and I would say that at some point in time they should be linking nucleotides and nucleic acids to organic chemistry. Now I know organic chemistry because that's where my medical degree comes from. My MD is not from anatomy, but rather from the organic chemical point of view. That's where I began my work, is on organic chemistry, and then branched out from organic chemistry and started doing organic chemistry in the body. Because I realized a lot of the stuff that we're talking about, and here we go. It says they have it under organic chemical nomenclature, right? The nomenclature is basically your names. The following entry has been prepared by a limited number of selections from two reports. The report of the Commission of the Reform of the nomenclature of organic chemistry, from the translation published in the Journal of American Chemical Society, volume 55, number 10, page 3905, October 1933, and the 1957 report of the report of the Commission on Nomenclature of Organic Chemistry of the International Union of Pure and Applied Chemistry, published in the Journal of the American Chemical Society, volume 2, pages 5,546 to 75, and they have this reference date here. So they've got a reference date here of 1960. So they said that they were going to have two references and two reports, but they actually have three in here. I say they go to the, and the way you basically name this goes into the naming of the various different chemicals, and they talk about organic chemistry in the term of hydrocarbons. And basically, your basic structure, if once you get into organic chemistry, is your basic chain structure. Your molecular structure is hydrogen bonded to carbon. And carbon will accept, because it's got 4 valence electrons, carbon will accept four bondings of hydrogen. So when we look at this, and see, so the most basic chemical formula that you can get in hydrocarbons in organic chemistry is CH4, and they term that methane. Right? So methane, if you know methane gas has the equation, the chemical equation of CH4. Basically, you put a C in the middle, you put 4 sticks, like a compass, and you put H's all around it, right? So there's then be 4 H's on it. So that's your chemical stick diagram of this. And I think I can do a bit of a drawing here to give us a little bit of a look at the chemical structure of the basic chemical structure of methane. So what I'm going to do is I'm going to draw a C. Then I'm going to put little sticks around it, like this. Let's see if we can see that here. Right there. No, can or can't see that. Yeah, there we go. Right there. And I'm going to put H's at the points. So now you're looking at it like this. And this gives you the chemical formula of CH4. And this is the structural diagram. This is the structural diagram of methane, your basic hydrocarbon. And then this here is your chemical formula, the basic chemical formula. Now it does get a little more complicated than that, because what ends up happening is that as you start moving up the ladder, what you have to do is you have to chain these molecules together, and you can't create new places. You only have the 4 places to work with. So the next chain up, the number 2 spot, because methane is simply the 1 carbon. Ethane is 2 carbons, and the way this is done is you have the 2 carbons linked together like this. Here we go. Here's the 2 carbons linked together like that. And the only room that you have left, because that middle part is taken up here, and it's shared between the both of them, you've only got 3 spaces left. 3 spaces that you can fill up with hydrogens. Like this. And now, to get, let me do this a little bit better. To get the chemical formula, all you need to do is count the number of carbons. We have 2 carbons, and we have 6 hydrogens altogether. But that's not your basic formula. That's the step to the basic formula. And what we do is we bring it down. We take our common element, which is 2 here. And so what we see here, if we just count one side of it, if we just count one side of this hydrocarbon, right, like that, we see you have 1 H, 1 C, and 3 H's. And so the basic compound that comes out of that, this is the formula for methane. This is the formula for methane. The C2H6, this is the formula for ethane. But we're given on the ends here a new chemical structure of CH3, and we are so what we're going to do next is we're going to do the next one up. The next one up is the 3-carbon chain, and the 3-carbon chain is called propane. And this is giving you the base. It does get more complex than this. Right now we're dealing with the more simple aspects of this. And so we do the same thing. We've got the three carbons. We've got the 3 carbons down below for number 3 for the propane. And I'm just going to number on the sides. Methane was number 1. Number 2 was ethane, and now we're working on number 3, which is propane. And if we do our stick diagrams again, we see on the leftmost carbon, we have room for 3 hydrogens, and on the rightmost carbon, we have room for 3 hydrogens. But in the middle carbon, right, in the middle here, you only have room for 2 hydrogens on the top and the bottom. And so our diagram now, writing out propane, looks like this. Yes, that's the chemical equation for the chemical diagram. It's just an equation. The chemical diagram for propane. And now, doing the basic chemical formula for propane, all we need to do is count the number of carbons and count the number of hydrogens. So we have 3 carbons, and we have altogether the 6 plus 2 more hydrogens, so that's 8 hydrogens. So the chemical formula for propane is C3H8, and we've got a new basic element here, and these are the elements, the hydrocarbon element, which is CH2, and the CH2 we can see fits in the middle of the hydrocarbon chains. And most people know methane from natural gas. Few people know about ethane. Ethane was an older structure that was used. Most people know about propane, and now we're going to get into the next one, the 4th one up, which is butane. So we're just going to draw a little thing here, and I'm going to squeeze it in here because we're kind of running out of room on the paper. So we're going to squeeze in a butane. So butane, we're doing number 4. We're doing butane, and because it's number 4, we know that we have four carbons in this. Right? The number tells us how many carbons are in this particular chain. So I've written out that we've got 4 carbons, and there's that in there. And now it's a little squishy. Actually, I want to write it out better. We got some more space, so I'm going to write it out better. And we're not going to see the butane structure because it's the end of this segment, and we are into organic chemistry. See you next segment, where we will continue on in organic chemistry and see the structure of butane.